Hello students, let's continue with chapter 8 quadrilaterals. We'll take a look at question 5 wherein you need to show that if the diagonals of a quadrilateral bisect each other at right angles, then the given quadrilateral is a square. So we've been given two things, that we have a quadrilateral ABCD wherein the diagonals are AC and BD. Now these diagonals are bisecting each other at right angles. That means O is the bisector because they are getting intersected at point O. So this implies that OA is equal to OC and OB is equal to OD, as well as they are bisecting each other at right angles. Therefore, each of these angles over here, AOB is equal to angle BOC is equal to angle COD is equal to angle DOA. So this is our given data. Now we need to prove that quadrilateral ABCD is a square. So how do we prove that quadrilateral ABCD is a square? Let's come back to our definition and our understanding of what a square is. We know that a square is a quadrilateral in which each of the sides are equal. That means we need to prove the first thing is AB is equal to BC is equal to CD is equal to DA. Also we have learned that a square is a parallelogram. So we need to prove that quadrilateral ABCD is a parallelogram. So this is the second thing that I need to prove. And the last thing that I need to prove is that each angle, that is angle A is equal to angle B is equal to angle C is equal to angle D is 90 degrees. This is also a property of 90 degrees that differentiates your square from a rhombus. A rhombus is also a parallelogram, and in a rhombus also we have all the sides equal. But what is the difference between the square and a rhombus is that in a rhombus the square is slightly tilted. So even if the sides are equal, the angles are not really equal. Let's go ahead and prove all these requirements in a sequence. So we will first need to prove that AB is equal to BC is equal to CD is equal to DA. So if I take this first section that I need to prove, AB is equal to BC. To prove that AB is equal to BC, it is very simple. If you take into consideration these triangles here, the triangles formed by the diagonal AC. I'll say proof for my first part. Here see, they are congruent to each other by the side angle side test of congruence. How did I say it so quickly? Because I can see the single dash over here. O is the midpoint for AC. I can see this as the common side, right? BO or OB, as well as I can see right angles here. So you have side angle side test of congruence. Since you prove that these two triangles are congruent, you can say that AB is equal to BC by corresponding pair of congruent triangles. And similarly, you can prove that BC is equal to CD by taking these two triangles, that is the two triangles formed by BD as the base, BO and OD as their bases, that is BOD and DOC. So once you prove these two triangles congruent, you can prove these two sides congruent. Similarly, you can take these two triangles here, COD and AOD, and prove that the two triangles are congruent and CD is equal to DA. So let's quickly go ahead and write this all down because this is a pretty lengthy sum. So for my first section, I am going to take in triangle AOB and triangle COB. I have AO is equal to CO because O is the midpoint of AC. Then I have OB is equal to OB because it is the common side, and I have angle AOB is equal to angle COB. Why? Because each of these is a right angle. So each is equal to 90 degrees. Therefore, I am going to say triangle AOB is congruent to triangle COB by side angle side test of congruence. Therefore, let's write what is required, that AB is equal to CB. Why? Because corresponding pair of congruent triangles. But we need to prove that AB is equal to BC, so let's just write this. Therefore, AB is equal to BC, right? I'll say 1. Similarly, what can we prove? That BC is equal to CD and CD is equal to DA, right? So we have also seen how we will prove these two triangles congruent. In the similar manner, you are going to take adjacent triangles. So I will say similarly, we can prove that BC is equal to CD and CD is equal to DA. I will mark this as 2. Therefore, what do you get from 1 and 2? Equals that are equal to the same thing are equal to each other. So I will say therefore AB is equal to BC is equal to CD is equal to DA, and I will say from 1 and 2. Right. So we have proved our first section. Let's tick it. Now we need to prove that quadrilateral ABCD is a parallelogram. It's a trend we have seen that in order to prove any two triangles as parallelogram, we were either looking at the alternate angles. That is the only thing that we've been looking so far to prove two triangles, to prove the quadrilateral is a parallelogram, or sometimes we take into consideration the sum of interior angles, right. So let's see if we can prove any two alternate angles congruent to each other, and then say that the triangle, the given quadrilateral is a parallelogram. Now first of all, if you notice, we have proved that AB is equal to DC. Let's mark this over here with 3 dashes. Oh, 3 dashes, not 4 dashes. Okay. We have proved that AB is equal to DC from here, or CD. It means the same thing. Also, if I manage to prove somehow that angle ABO is equal to angle CDO, they form an alternate angle for lines AB, CD and transversal BD. Don't you think if these alternate angles are equal, I can say that these two lines are parallel? So if you have in a quadrilateral that the opposites, any pair of opposite sides are equal and parallel, you can say that the given quadrilateral is a parallelogram. So let's see how we are going to prove this as an alternate angle. If you notice triangle AOB and triangle COD, everything is given over here. You can either prove these two triangles congruent by the side test of congruence or the side angle side test of congruence. So let's say we'll just go about proving it using the given data. So we'll say prove it by side angle side test of congruence. So I'll say my second part, in triangle AOB and triangle COD. What do you have? You have AO is equal to CO. O is the midpoint of AC. Why O is the midpoint of AC? Because AC is getting bisected by the line segment BD or the diagonal BD at O. So O becomes the midpoint. Also I have OB is equal to OD. Again O is the midpoint of BD. Correct? And my angles here are 90 degrees. That is angle AOD is equal to angle COD. Why? Each is 90 degrees. Because the diagonals are bisecting each other at right angles. Therefore, I will say that angle ABO is equal to angle CDO. Why? Through corresponding pair of congruent triangles. But we need these entire angles, right? ABD and BDC congruent. Why? Because we need to show that these two lines are parallel for my transversal BD. So I do not need to stop at O. I need the entire line segment BD and DB in both the cases. That's why I am going to extend this ABO to ABD and CDO to CDB to make them the entire angles and make BD as my transversal for lines AB and CD. Okay? And also because O lies on the line segment BD. So let's rewrite this. I will therefore have angle ABD is equal to angle CDB, right? So now, therefore, what can I say? That AB is parallel to CD. AB is parallel to CD because these are a pair of alternate angles. I'll say alternate angles for lines I'll say alternate angle theorem, because you can see that these two are a pair of alternate angles for lines AB and CD. So let's mark this as, we'll mark this as 3, let's mark this as 4. So from 3 what do you have? We have AB is equal to DC. AB is equal to DC, I'll say from 3. Let's mark this as 5. So what can you say from 4 and 5? That quadrilateral ABCD is a parallelogram. Therefore, quadrilateral ABCD is a parallelogram from 4 and 5. Let's mark this as 6, because you never know when you will be needing references. So we have proved our second point. Now we need to prove the fourth point, wherein you need to prove that the entire angles A, B, C, D are equal to 90 degrees. All of them are equal and they all are equal to 90 degrees. So if you take into consideration, let's say if you want the entire angles, you will need a triangle such that the triangles will have the entire angles. We do not want half of these angles, or ODC. We need the entire angle ADC, we need the entire angle BCD, we need the entire angle CBA, we need the entire angle DAB or BAD. So if you take a look at two triangles at the base DC, what do you have? You have ADC and you have BCD. Can't you prove them? Let's see if you can prove them congruent or not, and thereby prove that angle D is equal to angle C. So the figure has a lot of markings on it. Let us just draw the two triangles and see if you can prove them congruent. This is not an exact replica of the triangles, but this is just for our understanding. So please ignore if they don't look congruent to each other. So I have ADC and BCD. We have proved over here that the sides are equal. This is the common side, and it's given that the diagonals are equal to each other. That means AC is equal to BD. Therefore, what can I say? My two triangles are congruent to each other by which test? Side test of congruence, and therefore I can say that entire angle D or ADC is equal to angle BCD. So let's prove this first, and then you will see how we are going to go about proving that each angle is 90 degrees. Alright. So my third part, in triangle ADC and triangle BCD, I have AD is equal to BC, I'll say from 3, then I have DC is equal to CD. Why? Because it's the common side, and I have AC is equal to BD, which is given that the two diagonals are equal to each other. We have this over here in the given, AC is equal to BD. Therefore, I am going to say triangle ADC is congruent to triangle BCD. By which test? Side test of congruence. Therefore, let's show that the two base angles, that the entire angles ADC and BCD are equal to each other. Therefore, ACD is equal to angle ADC is equal to angle BCD by corresponding pair of congruent triangles. Let's mark this statement as 7. But what do you have? You have ABCD as your parallelogram. That means AD is parallel to BC and DC is the transversal. So angle ADC and BCD is going to be, the sum of these two angles is going to be 180 degrees. Why? Because they form the interior angles on the same side of the transversal DC, right? So what will I say? But AD is parallel to BC. We prove that using 7, using point number 6, which states that quadrilateral ABCD is a parallelogram. Correct? So, but AB is parallel to BC and DC is the transversal. Therefore, what do I get? Therefore, angle ADC plus angle BCD is equal to 180 degrees. I will say interior angle theorem. We have learned that the sum of interior angles on the same side of the transversal, in this case the transversal DC, 180 degrees. And I will mark this as 8. So, instead of ADC out here, in this statement, I will just substitute BCD because both the angles are equal. So, I will say therefore, angle BCD is plus angle BCD is equal to 180 degrees. Potato plus potato is 2 potatoes. So, BCD plus BCD is 2 BCD is equal to 180 degrees. Therefore, angle BCD is equal to 180 degrees divided by 2, which is equal to 90 degrees. Correct? Therefore, angle BCD is equal to angle ADC is equal to 90 degrees, and since we are taking this into consideration, I will say from 7. Similarly, you can take your two triangles. Which two triangles? DAB and CBA. Prove them congruent and show that these two angles are equal to each other, as well as they are the interior angles for parallel lines ADBC and transversal AB. Therefore, twice of any of these angles is equal to 180 degrees, which means each angle is 90 degrees, right? So, I will say, let us mark this as point number 8. I will say, similarly, we can prove that angle DAB is equal to angle CBA is equal to 90 degrees. Let us mark this as 9. So, we will continue over here. What do you get from 8 and 9? Therefore, angle DAB is equal to angle CBA, which is equal to angle BCD, which is equal to angle ADC, which is equal to 90 degrees. Why? Because equals that are equal to the same thing are equal to each other. But what do we need? We need complete angles A, B, C and D. So, if you notice, DAB is nothing but angle A, angle CBA is nothing but angle B, angle BCD is nothing but angle C, and angle ADC similarly is angle D, which is equal to 90 degrees. Hence, just to prove that my quadrilateral ABCD was a square, using the given data that the diagonals bisect each other at perpendicular angles or at right angles, we had to prove the entire board, and we are left with no space to solve the other question, that is question number 6. So, let us take a look at it in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.